Now it's the time to demonstrate confidence interval calculation based on a single sample. In this demonstration, first we will compute the standard error. For each of the 1000 samples separately, we will use the formula we just learned, SE, that is standard error, is equal to standard deviation of each of the sample divided by square root of n is 100 in all these samples. So SD is the sample standard deviation and n is the number of participants. In the second step, then we will determine the 95% confidence interval bounds. The lower bound will be calculated by the sample mean of that respective sample minus the standard error times 2. In reality, it is 1.96, but 2 is fine for practical purposes. And then we will measure the upper confidence interval. That would be the sample mean of a respective sample plus 2 standard errors. And then we will also like to validate against the unknown mean. We will calculate how many of our 1000 simulated confidence intervals include the true population means in order to confirm 95% confidence coverage. So let's get started. Okay, step 1, let's calculate the standard error using formula which we have it on our screen. Standard error is equal to standard deviation of each sample divided by square root of n. Okay, so standard error, this is equals to the standard deviation, which is in fact STDEV, and then I'm gonna just point and click the whole sample from cell D2 all the way to CY2 and parentheses close. So this is giving me the standard deviation of the first sample, and I have to divide it by square root of n, SQRT, and we know there are 100 individuals in this sample, parentheses close, parentheses close. So we have calculated the standard error for the first sample, which comes down to be 1.33, and if you see, it is pretty close to the we would say the real standard error, which we would never know because we will never have 1000 samples. But even with this formula, we were very close to the real standard error of the population, 1.33. Next, let's calculate the standard, the lower bound for the confidence interval by the formula which we just saw. Okay, so the lower confidence interval would be the mean of that sample minus minus parentheses 2 times standard error, right? Okay, and the upper bound would be, upper confidence interval would be equals to sample mean plus 2 into standard error, which is this value. And in fact, we should put it in the parentheses so we do not mess up the calculation. Okay, and we see that the upper bound is 86 millimeters of mercury. So what it is explaining is that, okay, the sample mean is 83.245, but when it comes to the whole population, we think that in 95% of the cases, it would be somewhere between 80 and 86 millimeters of mercury. Let's calculate it for all the samples, and then we will verify how many of these 1000 samples were able to capture the true population means. Okay, so I'm going to just grab the fill handle and drag it down all the way to 1000 samples. Okay, so here's the standard error of all of these samples separately, and then double click on the second low confidence interval and for the upper confidence interval. Okay, now in the third step, we are going to verify how many of these samples were actually able to capture the real population mean, which was in the real world would be in fact unknown. Okay, let's label our column dk as verify, and I'm going to use this formula here, equals if, I'm going to explain this formula in a minute, if and another parentheses, and I'm going to go to the actual value B, which is in cell B2, and I'm also going to lock this value, and I will explain why I'm going to lock this value, function f4. Okay, if this value is greater than or equal to lower confidence interval, greater than equal to the lower confidence interval, or and this value is greater than, smaller than equal to the upper confidence interval, then Excel, please give me 1. If they are not in between these two values, then give me 0. Parentheses closed, and enter. Okay, so what is this formula giving us is that if the actual confidence interval, which is the actual population mean, which is going to be in the real situation will be unknown, if it is between this value and this value, it is going to return with the value 1. If it is not in between these two values, lower and upper confidence interval, it is going to give me 0. So in the first sample, we were able to capture the real population mean. Okay, and then we see that in the second, if the lower is 79, upper is 84, and we know that the actual population mean is slightly above. So in the second sample, we went wrong. We were not able to capture the true population mean, but in the rest of them, we were able to capture. Then there is another sample we were not able to capture. So let's see how many were of these 1,000 sample did capture the population mean. Okay, and confirm, just labeling them at random kind of headers. Okay, count this dk to dc count f, sorry, count f, this to this is 1. Okay, and it gives me the values that there are out of 1,000 values, 965 did contain the true population mean. I'm going to divide it by 1,000, the total number of samples, and we see that perfectly 95% of all these samples were able to capture the true population mean. Okay, now let's verify it further and replace the diastolic values with maybe age at start. Okay, go back and replace it with age at start. Okay, and let's see how many times. Again, perfectly 95.4% of 1,000 samples were able to capture the true population mean perfectly. Let's try with one more, maybe with the smoking status. Okay. And we see that again, very close to 95% values, we were able to capture the confidence interval perfectly. Okay, coming full circle. In summary, a confidence interval implies that if we repeat the same study multiple times with different random samples of the same size, approximately 95% of those intervals would contain the true population means. And then we just demonstrated that you can in fact measure the confidence interval using single sample only quite perfectly. Right? Okay, thank you very much. I'll see you in the next video.